Have you ever wondered why the sky glows with stunning colors? Join us as we uncover the amazing science behind the northern lights. In this video, we'll explore how solar winds from the sun create these dazzling displays in the night sky. Get ready to learn how space weather, solar cycles, and Earth's magnetic field work together to create these spectacular light shows here on Earth. Hello friends, I'm Aurora. Welcome back to my channel Bright Spark. And today I'm going to teach you the cool science behind the northern lights. From solar winds to the sun to Earth's magnetic fields, let's explore how these magical lights appear on our night sky. Let's go! Do you know the northern lights are caused by weather in space? The sun constantly sends out electrically charged particles called solar wind. When these particles hit Earth's magnetic field, they create the most spectacular light show in the sky, the Aurora Borealis. Earth has a magnetic field, just like a giant magnet. When the solar wind interacts with this field, it stretches like a windsock. And guess what? When the field snaps back, it sends charged particles crashing into Earth's atmosphere. That's when we see the northern lights. Do you know that when the sun is more active, we see more auroras? 2025 is the peak of the solar cycle, which means this year is one of the best times to catch the northern lights. You can spot the northern lights across Canada, the northern US, and parts of northern Europe. They light up the sky in stunning colors like green, red, and yellow. And guess what? The auroras don't just happen in the north. There's also a southern lights version near the South Pole. When the solar wind is strong, the auroras glow even brighter and change colors. And during powerful space storms, they can spread further south than usual. So, you might see them even if you don't live near the Arctic. The term Aurora Borealis was coined in the early 17th century by the renowned astronomer and scientist Galileo Galilei. The name comes from two sources: Aurora, the Roman goddess of dawn, and Boreas, the Greek name for the north wind. Galileo believed that the aurora was caused by sunlight reflecting off the atmosphere. A theory that we know now isn't quite accurate, but it sparked curiosity and opened the doors for further scientific exploration. The colors of the aurora depend on how high up in the atmosphere the charged particles from the sun collide with different gases. When these particles interact with oxygen and nitrogen, they excite atoms, which then release energy in the form of colorful light. Green is the most frequently seen aurora color because the Earth's atmosphere contains a lot of oxygen at this altitude. When the solar particles collide with the oxygen molecules 100 kilometers above the ground, they excite atoms, which then release green light as they return to their normal state. Red auroras appear when solar particles hit oxygen at much higher altitudes, around 250 kilometers or more. So, red auroras are less common and often appear faint or mixed with green. Nitrogen is responsible for the stunning purple and blue auroras. These colors occur when charged particles collide with the nitrogen molecules in the lower parts of the aurora below 100 kilometers. Blue appears when nitrogen atoms are directly excited by energetic particles. Purple occurs when both oxygen and nitrogen interact, creating a beautiful blend of colors. Can astronauts see auroras? Yes! Astronauts aboard the International Space Station get a front row seat to the auroras from space. Imagine looking down at the light instead of up. Did you know auroras can make sound? Some people claim to hear faint crackling or popping sounds when the auroras are really strong. Scientists believe this could be caused by electrical activity in the atmosphere. The best places to watch auroras are near the North Pole, like Norway, Iceland, Canada, Alaska, and Finland. There's even a special aurora sky station in Norway where people travel just to see the lights. How high are the northern lights? Auroras happen 100 to 500 kilometers above Earth, but during big solar storms, they can reach 600 kilometers high. That's higher than the International Space Station. Did you know that geomagnetic storms caused by solar winds can sometimes affect power grids on Earth? That's why scientists study space weather to keep everything running smoothly and to tell us the best times to see the aurora. And that's all for today. If you enjoyed this video, please don't forget to like, subscribe, and hit the bell button. Thank you. Bye-bye.